Hi, hello, how are you? My name is Anakin Bensel. Welcome back to my channel. We are on day 23 of the July LeetCode or the Juleetcode challenge. I'm answering all these in Python, and today we are just as disappointed as yesterday because I still did not do as well. This time we're over 30 on both. However, we still have tons of room for improvement. So I wanted to go over my answer that I submitted. It took me about 9 minutes and 20 seconds to write this, just to solve this, but tack on another 10-ish or so minutes to read through the problem and completely understand it. So give it about 19 to 20, 22 minutes max. And I wanted to go through, it's question number 894. And again, the solution is in Python. You guys are more than welcome to read through this question on your own time. I felt like it was pretty clear. Oops. The instructionals, like the didactic instructionals here, were actually super helpful. So yeah, submissions. So let's start with how I broke down this code. I started off with a couple base cases. So this is my first base case here, which basically is a base case that n must be odd and greater than 0. My second base case here, this one, is if n is 1, return the tree with a single node. And then we would use this area here. Sorry, I'm trying to highlight these. I don't have my mouse. I have my just regular trackpad. What was I saying? This is the area where we list, like the list to store all the possible trees. Goodness gracious. This little section here basically would generate all the possible combinations of left and right subtrees. And then down here, from about here to here, there we go. We create the full binary trees by combining the right and left subtrees. And then obviously down at the end, we have the return result. So that is how I approach this problem. There's definitely a better way to do it. And I think what I would have done, differently is, I don't know, to improve the runtime and memory usage. I think I would have kind of avoided the kind of redundant computations, because some of these can be really redundant. I'm not sure exactly how I would have done that, but I would limit the recursion that happens to generate the full binary trees, essentially. But that's neither here nor there. And as you can see, I'm over 30% on each, but I'm like not thrilled with that. So that is my solution today. I will leave my GitHub link in the comment or in the video description down below. You guys are more than welcome to fork and clone, make this better, make it worse. I don't really care as long as you're learning something and having fun. And I will see you guys in the next video. Thank you guys so much for watching.